poor quality data cost businesses trillions of dollars each year. That's right, messy, inaccurate, or incomplete data can lead to big mistakes. But the good news is, with the right techniques, we can turn messy data into gold. In this lecture, you will learn data cleaning and transformation, two critical steps in preparing data for analysis. You will also know how to identify problems in data, clean it effectively, and reshape it into a format ready for analysis. In this lecture, you will understand the importance of data cleaning and transformation, learn common techniques for cleaning messy data, discover how to transform data into usable format for analysis. When data is messy, it's like trying to solve a puzzle with missing or mismatched pieces. Cleaning ensures that all pieces fit together correctly. Transformation reshapes those pieces into patterns that make sense for analysis. Without these steps, even the most advanced tools and methods would not deliver reliable insights. Imagine a desk covered with papers, pens, and random items. To work efficiently, you first sort out the clutter, throw away what you do not need, and organize the rest into drawers. This is data cleaning. Then you arrange the items you need for a specific task, like putting your notebook and pen side by side. This is data transformation. A cluttered desk, like messy data, makes work difficult. Cleaning and organizing it ensures you can work effectively and efficiently. Cleaning messy data is crucial for ensuring accurate analysis and reliable insights. Here are some effective techniques to clean and organize data. The first step is identifying errors in your data. This includes duplicates, typos, or inconsistencies. For example, imagine a dataset where California is spelled as Californa or entered as CA in some rows. Cleaning involves standardizing these entries. Missing data is a common problem. You can handle it in a few ways. Fill in missing values using averages, medians, or predictions. Remove rows or columns with too many missing values. For example, if a dataset tracking sales has missing entries for one region, you might use the average sales from other regions to fill in the gap. Validation ensures that data meets specific rules. For instance, if a column is supposed to contain dates, any value that isn't a valid date is flagged for correction. Once the data is clean, transformation makes it usable for analysis. Normalization scales data into uniform range. This is particularly useful when working with different types of data. For instance, if one column tracks sales in dollars and another tracks percentages, normalization ensures they are comparable. Reshaping involves organizing data into a format that suits your analysis. For example, you might turn a dataset with multiple columns for monthly sales into one column for months and another for sales. This tidy format is easier to analyze. Sometimes data from multiple sources needs to be combined. This is called merging. Other times, a single column might need to be split into two, such as separating first and last names from a single name column. Choose a messy dataset. You can download one online or create one yourself. Clean the data by identifying and correcting errors, dealing with missing values, and validating entries. Then transform it into a tidy format ready for analysis. In summary, data cleaning and transformation are essential steps in preparing data for analysis. We cover techniques for cleaning errors, handling missing data, and validating entries, as well as methods for reshaping and normalizing data. Let's discuss, what do you think is the biggest challenge in cleaning and transforming data? Share your thoughts in the comment section. This marks the end of this lecture. See you in the next one.